just a reminder with radians, it still starts with a 0, but then remember it's like pi over 2 pi for each of the axes. And if you're still like needing a little bit of reminder, remember the coordinates go cosine comma sine. See, can I have you slide over a little bit?
I don't get that. Like, why is it, like, what is cosine comma sine? Like, I get that it's like a coordinate, but like.
The coordinates come from this unit circle. So all of these have this point. This point would be 1 comma 0. So the cosine would be 1, the sine would be 0.
So it's like x and y. Or like.
Yeah, but they're just, that's where you get your cosine and your sine from.
Maybe.
So I'd like you guys to find the values of each of these. And again, using it without a calculator, if you were to check it with your calculator, you would need to be in that radian mode because these are talking about radians rather than degrees. Now, you don't have to fill in the whole unit circle today, or you won't need to for our notes here, because we're really only going to deal with these axes. If you filled it in, it's not bad, but we're going to end up dealing with just like the axis. So on this, you guys, just to kind of make sure you guys are all seeing what we're needing to do here, if I ask for the sine of pi, I go over to where pi is, and I look at the second value, because sine is the second value in terms of x and y. So the sine of pi would be 0. So that's all I'm asking you guys to do in this case. Now again, if you wanted to check that with your calculator, like just to be sure that I'm not just like making this stuff up, that it's not, you know, like this is a fact that the sine of pi equals 0, again, you'd have to be in that radian mode. So I'm asking you then the cosine of pi over 2, the sine of 3 pi over 2, the cosine of 2 pi. So all of those values should either be like 0, 1, or negative 1. So we'll hopefully be able to fill the rest of those in here in a second. I'll give you guys a minute to try those. Because we're going to be dealing with these angle measures specifically today to kind of help us to understand the graphing. So cosine of pi over 2. So we're up here, cosine of pi over 2. So cosine's the first term, so cosine of pi over 2 is just 0 again. What's sine of 3 pi over 2? Negative 1. 3 pi over 2 is down here. The sine is the second value, so that would be negative 1. Guys, off your phones, please. And then the cosine of 2 pi. So 2 pi would be all the way around. So that would just be 1. So understanding that these values, you should just be able to figure them out based on where you're at in the quadrant or in the axis. Now, this is not something you're going to have to do all the time, but I want you to start thinking about it a little bit here as we're graphing today, because it's going to help you understand the graphs. Now, one of the things I want to ask you then is then what would be, let's do the sine of 5 pi. What would be the sine of 5 pi?
0.
So I heard 0.
I'm at 0.
You're at 0 as well. So if we go around, we start at 0. We go around, we're at 2 pi. Go around again, we're at 4 pi. So at 5 pi, we're over here. So yeah, sine of 5 pi would be 0. The cosine of 5 pi would be -1. So what I'm going to get you guys to hopefully see today is that sine and cosine graphs are what we call they're kind of cyclical, that they keep doing the same cycle. And it's because they keep going around this unit circle again and again. Kind of the same idea we talked about the hands of a clock, that it keeps spinning around and it's still, they look the same, but it's a different time. So we're going to use that to understand the idea of sine and cosine graphs. So this first chart says graph the sine and cosine functions by using your unit circle and your angle measures. Now, I don't want you guys just to start and try to tackle this without any instruction. I'll explain what I mean by that. So what we're going to do is we're going to write the angle here. And then, and that's going to be our x value. And then we're going to write the sine or the cosine of that. So the sine of x over here. So that'll be our y. Now I'm going to pick angles that are kind of strategic, that are nicer to pick, just like if you guys were doing graphing in algebra, you would pick nice points. You wouldn't pick -500 to graph. It wouldn't be a nice point. We're going to pick nice points. So I'm going to pick points that are going to be kind of strategic as we pick these. So I'm going to start with 0. I'm going to go pi over 2. I'm going to go pi, 3 pi over 2, 2 pi. And we could repeat that, but we'll talk about that in a second. Now again, the warm-up question is trying to get you to start thinking about that. So sine of 0, how much is that? It's 0. Sine of 0 is just 0. So that's starting in our axis, we would be over at the 0 line. So sine of pi over 2, so now we're straight up. That's going to be 1. Then sine of pi, which is this way, or 180 degrees, is going to be 0 again. 3 pi over 2, so straight down, is going to be -1. And then 2 pi, back around, 0. And then hopefully you realize that this would just keep repeating. So if I then went to the next, so what would that be, 5 pi over 2? Or if I went to 3 pi, it would keep repeating as we go through this. So what we're going to do is we're going to graph our sine function on this graph paper. And this graph paper is kind of nice because they actually used radians rather than degrees. So they have pi over 2 and pi. They're spaced equally because that makes sense. Now, do you guys want to make it just one straight up, or do you mind if I skip? What do you want to do? Is one just the first line? Okay, that bugs you. It's not probably yet. So 1 and -1. Now, if I knew going into this that I'm only going up to 1, I would maybe space it out a little bit more. But when we go to graph this now, when x is 0, y is 0, I'll put a dot there. So just like a normal graph. Now we're going to go over to pi over 2. When x is pi over 2, what's the sign going to be? 1. So I'm going to go up to 1 here. At pi, it's back at 0. 3 pi over 2 is -1. And then 2 pi is back at 0. So what we just did is we kind of showed the sine curve. Now, knowing what I know about graphs, I'm going to draw this as a curve. Now, maybe if you weren't comfortable with graphs, you might just draw that as kind of like a little zigzag there. But it's going to have a curve to it. And it has that kind of a wave to it. And this would keep repeating. So if I kept drawing, I could go all the way down the hallway doing this same curve. It would go up to 1, down to -1, and just keep repeating. Because that's what our sine graph always does. It keeps going around in that same circle. So that takes us to our cosine graph. So I'll give you guys a minute to see if you guys can see how this is different. If you're nervous that you're going to write something wrong, maybe write in pencil, or don't write quite yet on the graph. So again, if I use those same values, those nice values, but careful, they're not the same graph. They're very, very similar, but they're not identical. So think back to our warm-up. Before you get too far, what's cosine of 0? What's cosine of 0? It's 1. Straight out to the side, it's just 1. So careful about that. If you start in the wrong spot, this is going to drive you crazy the rest of it. So you're going around the unit circle. So straight up should be 0. And again, I'm referring back to these coordinate points. Again, kind of what Kat was asking about right in the beginning. What's cosine and sine there? That's exactly what we're talking about. Pi would be -1. 3 pi over 2 would be 0. And then this is 1 again, and again this would repeat. So this graph should be slightly different than our sine graph, but has a lot of similarities. So 0, 1 is my first point. Pi over 2 goes back to 0. Pi is -1. 3 pi over 2 is 0 again, and then 2 pi is back at 1. So this one, rather than starting at 0, it's going to start up at 1, and then go down, and then back up again. And again, you're trying to make this look like a curve as much as you can. If it looks like a straight line, I just try to make it, that's why I was going to try to go higher and lower. It actually makes it look a little bit better when you stretch it out a little bit more. But we want to make this should be a rolling curve. Kind of almost picture like the circle, like you're going around the circle, and it's not like completely straight lines. Okay? So we're going to talk about, so there's some similarities and differences, and I talked about those a little bit already because it's hard not to mention. How are these two the same? Or how are they different? Give me anything that you've noticed, same or different. Yeah?
Sine starts at 0, cosine starts at 1.
Yeah. Right? Yeah.
They both have 1, 0, and -1.
Yeah, so like their main values are 1, 0, and -1. So there's no difference in that. So I'm going to write that up here. It's kind of our values that we're dealing with. Why are those points so important? Like why are the 1 and -1 so important? And maybe some of you guys who have been in pre-calc, what do we call those points? Like the top of the curve and the bottom of the curve. Like a max and a min. So what's their maximum point? 1. Do you, like, the basic sine graph is never to go over 1. It's going to be as high as it goes. So they both have max of 1 and a minimum of -1. How long does it take for them to each repeat their cycle again, to get back to the starting point? How long does that take? And you can think about the x as your time. Across the x-axis, how long until it's back at the starting point again? One rotation. What is that? Like how many degree or how many radians is that? Yeah. What's that? But not how. Like use the types of numbers we're using though. Yeah. 2 what? Not just 2 radians. Well, piling gets us halfway. So what takes us all the way? 2 pi. Yeah. So like. to get back to our starting point again. So you might say we might be there now, but no, we're not quite at the starting point. To get through the whole cycle, like the whole, like it's been summer, winter, the whole school year, the whole like calendar year, it takes a full 2 pi to get through that. Same thing with cosine. It takes a full 2 pi until it's back up to the top of the hill again. Think about this as hill repeats or something that you do repetitively. To get back to our starting point again, it takes us a full 2 pi. So we say the cycle, or we're going to call that the period, is 2 pi. So we'll mention that down here. So I'm just saying, like, the same length of the curve would be a similarity, is how long it takes to get back to the start. And that's important to kind of be aware of. So we call these types of graphs periodic. It means it keeps repeating. You hear about the word periodic, like when you talk about insurance or interest rates, like that it keeps like happening, that you keep getting an interest, like if you're not paying your credit card, you have a periodic interest rate. So keeps repeating. Weird. And then we'd say one complete cycle for how long it takes to get back to the starting point. We'll call that a cycle. Now, when we talk about these equations, we're going to talk about some different values or variables. So I'm going to kind of write a standard, kind of a like y equals mx plus b, but using trig. So I'm just going to say trig rather than sine or cosine or tangent. And that should be a bx. So y equals a times the trig function, whatever that happens to be, of bx. So typically that can be written in parentheses. Now this sounds really fancy. The period of a sinusoid, which means basically something that looks like a sine function, is either sine or cosine. Really fancy word for that. Just to confuse you, make it sound like way complicated. You don't know what I'm talking about anymore. The period of that function is going to always be 2 pi divided by b. So the b we're talking about is going to be the b in this function here. And again, that's how long it'll take to get back to the start again in either situation. So that would be a full period. The next thing is the amplitude. What do you think amplitude would be? Just based on, what's that?
Increase.
Has something to do with the increasing, because you think about something being, amplitude being increased. They talk about amplitude of waves a lot of times. That's how high it goes. So how high or low our wave will go, our graph. So that's the amplitude. And I'll show you guys a quick little drawing of what I mean by that. So if there's there's a center line. The amplitude would be how high above that center line it goes, or how low, but not the two together, so it's one way or the other. And that comes from the absolute value of A. So, going back to our original two graphs we did. So if we're talking about our original two graphs, so these two, this is just sine of x, this is just cosine of x. So there's nothing in front of that sine, there's no value in front of that. So then we assume the amplitude is 1, because it just goes up 1 and down 1. There's nothing in front of the cosine, so it goes up 1, down 1. Same thing, there's nothing in front of x here. So that means the period is just going to be 2 pi, always, if there's not a value in front of that x. Now we're going to change that up a little bit. So the next two examples are going to allow us to change it. So I'd like you guys to look at those and decide